Hey there, math fans. I'm just going to be more of a quick little point of interest about shifting, dilating, and reflecting using my cat as an example. So, what I have there is a little triangle made up of these three lines, and we're going to move it around. I made it so the corners are nice, and I just want to play this game. So, let's just take one of these, but let's pretend I do it with all of them. And if I was in class, I would have students start giving me numbers, meaning we're going to throw a bunch of things in here. So let's say there's I don't know, how about a 3 here? And let's say we're going to do an F1. Maybe we'll do a -2. Maybe we'll do an X minus 3. I'm already used to 3 somewhere else. X minus 5. And let's do a +4. So we can, and so this is what I'm thinking, this might be a fun thing for the future, is to try to anticipate where the points go. What's going to happen to Penelope in her little triangle there? So if you just want a quick exercise, you can try that. I presented this in a couple different ways in class and in my review sheets. I kind of have once you know what you're doing, you can look at it directly and know, but we just don't do this very often. And so I have a proposal of kind of one specific way to do it, which is to move all the y stuff to the y side. In other words, all the outside stuff. So this is just good opportunity for us to think about our functions. I'm going to subtract the 4 and divide by 3. So I'm subtracting the 4 and I'm dividing by 3. This is not the only way to say this, and what I just did is not strictly necessary to do this, but I think based off of talking to a whole bunch of students today in office hours that they preferred this of the approaches. Okay, what I just did is separated the stuff that was on the inside and the stuff that was on the outside. What you're really doing when you're doing shifting and dilating is you're trying to say, how did this change relate to the graph I currently have? The graph I currently have is this. I tried in class to label this old X and old Y, and I was trying to make the explanation, this is how I think about it, but I realized it didn't work that well with students. I'm trying to think about what I would need to plug in to get those values. I have the old values, meaning I know what it looks like when this is 7. Let me shrink my picture for a second because I know I'm getting in the way. But what I like about this is we have at the end of the process a check. We're going to just graph it in Desmos. I think that could be something I've helped the students to have this immediate feedback in this way. Okay, so we know that when we plug in a 7, we get a 1, but what's going to lead to plugging in a 7? And what's going to happen here, what's the new thing, if this is a 1? So basically you're going to undo things. That's how I think about it. So I don't even, that's the one thing I remember about this process when I have to do it down the road, is I say, well, how do I get back to X here? What I'm really thinking, and I was trying to see how I could explain this to students in class, and so I wrote this, and I don't know that I did it very well when I explained it, is I said, this is your new variable, how does it relate to your old? Well, you're going to have to divide by -2, and you're going to have to add 5. So it's really like thinking in terms of solving. The problem with that is if you don't move all the y's over, then I have to teach you a new thing for the y's. And so I think the most consistent way after doing this is to think of it this way. Basically, what do I need to do to my old numbers, my 1s and my 7s, to get my new numbers? Well, I have to divide by -2 and add 5. So let's try that. Let's take the point 7, 1, and let's do it in 2 steps. So the first step for X is I'm going to get rid of this. So I'm going to divide by -2. So this is going to become 7 over -2. The first step for Y is I'm going to multiply by 3. I'm trying to undo that. the next step, if you're thinking about solving, is you're going to add 5. So you're going to add 5, 5. And I don't know if these numbers are nice. I made these up on the fly. I wanted it to be that way. And then we're going to add 4. This is just going to be 7. So I'm going to make a little note of that new point. It's going to be 10 fifths, so it's going to be 3 halves, 10 halves. Okay, that lower right corner is going to move to 1.57. So what I thought would be interesting the next time I do this is it just whatever I do, it seems to take time, and there's not enough time to like flesh it out completely. But let's just do it. So I want A to be 3. Ooh, that stretched it out. I want B to be -2. That's going to accomplish 2 things. It's going to reflect it over the y-axis, and it's also going to scale it. Oops, 2. Sorry, Penelope. It's the random numbers I picked. So far we've done those operations. Next, we are going to shift. Okay, and then we have it. An interesting thing happened there. I was confused for a moment. But the point moved. Now I'm going to show you the original corners. That point moved to the other side. I was confused for a moment because I was like, why isn't the lower right? But it's because we flipped. I thought maybe I had made a mistake. But there's that 1.57. And you could also track the other points. All right, I hope that's of interest to you. Let me know if that helps at all.